Okay, we're back, guys. What we want to do now is we want to construct some one sample t intervals. Now, when we construct our one sample t intervals, you need to know for the plan that the conditions are going to change a little bit from the proportion. Let's talk about that now. We still are going to we're still going to have a random sample. Okay, so we need a random sample of n equals whatever. And I do like you guys to put what that n is equal to. Okay, you can make an assumption on that. That is okay to proceed. If it doesn't state random, you can say we assume that it's a random sample. So we're drawing conclusions based off an assumption. The next one is our independence, 10, times our sample size has to be less than our population size. And then we have our n, our normal condition. This is going to be different. You learned this in Unit 5. When we're dealing with means, n has to be greater than or equal to 30. That comes from the central limit theorem. Or it needs to be part of the normal population. So it will state that your sample comes from a normal population. So even if n is not greater than or equal to 30, but it states it comes from a normal population, you can proceed. Now, what if it doesn't state that it comes from a normal population and it is less than 30? Well, the t distribution is what we call a robust distribution. So we can go ahead and we can still use our t interval and our t-test if a couple conditions are met. It really is only one. We just have to check and see where are we at. So let's say, anything n is greater than or equal to 30, I'll call a large enough sample size. But let's say we had a sample size of 20. I call a sample size of 20 a medium sample size. That's just my word for it. It's not the College Board, but it's a nice way to decipher what's going on here, and we'll talk about that more in a second. So if these don't work here, the first thing that we want to do is we want to graph the data. And then we look at it and we say, okay, well, what is our sample size? Do we have a medium sample size? If we have a medium sample size, that means that 15 is less than n, which is less than 30. Again, this medium is my word. It is not in any textbook. It's just my word for teaching. When we graph that data, what we want to look at is we want to make sure there's no outliers or no strong skew. Okay, no outliers or no strong skew. Okay, so it can have some skew, but just not like a super skewed one. And you'll get comfortable with this. It's going to feel a little uncomfortable at first because you're going to say, well, how do I know if this is strong or not? You'll get comfortable with it. You'll do enough where you've had enough practice with it. Okay, as long as there's no outliers or no strong skew, you can proceed. Now, what if it's not between 15 and 30? What do we do next? Well, I call that the small sample. Anything where n is less than or equal to 15, we still graph the data. And this time we can have no outliers, and it needs to be mostly symmetric. Again, you'll get comfortable if it's mostly symmetric or not by practicing in your homework. Let's get to the good stuff, the actual interval. Okay, a manufacturer of a high-resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output reading in millivolts. Some variation is inherent in the production process. Here are the tension readings from a random sample of 20 screens from a single day's production. Construct and interpret a 90% confidence interval for the mean tension of all screens produced on this day. A lot of times I'll get questions that will say, how do I know if I'm dealing with a P or a mean? You're dealing with a P, a one sample Z interval for P, when you're dealing with proportions, categorical variables. They will usually always state mean. They'll say construct a confidence interval for the mean, okay? For the mean. So let's go ahead. Let's talk about our state, plan, do, and conclude. First thing is for the state. With a confidence interval, all I need you to do is state the population parameter, okay? So that is mu. That is a Greek symbol. It looks like this kind of funny, like U/M or cursive M. Okay. You can just write out mu as well. Mu is equal to the true mean tension for all screens produced on this day. If you're getting nervous about the context, like you're like, oh, I'm not very good with context, use the problem to help you. I literally just copied this right here. State is done. Let's go to the plan. We just talked about our conditions, and then we have our method. I'm going to use a different color. I appreciated on the last test, many of you were very organized in your thinking. Makes it easy to grade, and it's better. Okay, so R, do we have a random sample? It states random sample of 20 screens. So stated random sample of n equals 20 screens. I, that's our 10% rule, so 10 times 20 has to be less than all screens. We're okay there. N, now 20 is not greater than or equal to 30. So the first thing we want to check is we want to say, does it come from a normal population? If it comes from a normal population, phew, we're done. We don't have to worry about it. But this does not say that it comes from a normal population. So now we need to go back to our notes and we say, okay, well, 20 is a medium sample, okay, a medium sample. So we need to graph the data and we need no outliers or strong skew. So let's go ahead and let's graph that data now. Grab your graphing calculators. Mine is right here. You notice here, guys, that we have data. We do not have statistics, okay? Just notice that. You're going to have to kind of keep track of that later on. We're going to go to stat. Okay, so everyone, we just went to stat. We're going to hit enter on edit. We're going to clear out our lists. And now in list 1, we want to enter our data right here. I'm going to pause the video right now so we can do that. You pause it as well. And then when we get started, everyone should have their list 1 filled out. Okay, so guys, we have all of our data in our list 1. I always encourage you guys to just double check that you've typed it in right, because one wrong move can really set the trajectory of the problem off, right? And so, and although we don't double ding in AP stats, it's just, you know, it just takes the stress out of it. Take an extra 5 seconds to double check that you typed it all in right. Now, what are we doing right now, guys? We are going to our stat plot. So that's second y equals. We're going to turn plot 1 on. And we want to check to make sure that there's no strong skew and no outliers. This one is nice right here because this one will tell us if there are outliers without us having to calculate it on our own, using that upper fence and that lower fence. As a quick little review to you, the lower fence, quartile 1 minus 1.5 times the IQR. Upper fence, quartile 3 plus 1.5 times the IQR. Everything should look like I have it right now on your calculator, and then you're going to go ahead and you're going to hit zoom 9. Okay, I have invalid dimensions, so I want to double check what's wrong. We'll do it again. Second y equals plot 1. Please work. I will have to double check what went wrong, but give me a second. I'll pause it and we'll go from there. Okay, you guys, I found what my error was. Sorry if this is a little disjointed right now with how I edited it. I didn't take the time to make it perfect. So what was wrong, just a couple things for you guys to check, is I did have something in my Y1 as well as my plot 2 was on. So just if you get errors like that, that's a couple of good places to look. I looked at my Y1 as well as my plot 2 was on. So just double check that. Now, when I go to zoom and I hit 9, you can see my graph, okay? And what we actually do need to do in this step when we do graph it, oh dear, I couldn't add it. That's a bummer. That's okay. When we do graph it, guys, we need to actually show the sketch of it. Now, if we look at our graph, you guys, this is very symmetric. There is no skew. There is no outliers. So it's just a sketch, you guys. It does not need to be perfect, but it's just showing your readers that you have checked it, you know this process, that you do need to check and make sure that there's no strong skew, no outliers. And this sketch of a box plot right there of what I think it looks like from my calculator, it does a nice job right there, okay? And that suffices. It is okay to proceed then with our method. Our method is one sample, T interval for mu. And forgive me in the midst of my minor panicking about, oh, I have an error. I forgot to also say what you need to say is no strong skew, no outliers. Okay, no strong skew, no outliers. If you wanted to put symmetric here, that's fine as well. I'm just kind of stick with what our notes say. Okay, we've done the state, we've done the plan, we have our method. Let's go ahead, let's do our do. Plug our numbers into our formula, okay? Plug our numbers into our formula. So we know, I'm gonna change the color here to red, and it's not letting me, awesome, not a problem. Do, we have our X bar first. So, well, what is my X bar? We need to go ahead and we need to figure that out, okay? And what we can do, you guys, is we can actually go to our T interval in our calculator. We could run a one variable stats and get our X bar and our standard deviation that way, but we could also go to our calculator and do it that way, okay? Let's do it with the one variable first because I think that is a good review. What am I doing right now? I have all of my data in my list one. I'm gonna go ahead and I'm gonna calculate one variable stats. I'm gonna hit enter. It should see list one, your frequency list should be blank, and I'm gonna go ahead and I'm gonna calculate. So I know that my X bar is 305.85. Okay, X bar is 305.85, so I'm gonna write that out. Plus or minus my degrees of my T star. I'm going to leave that blank right now. I'm going to do my standard deviation first. That Sx divided by the square root of n. So if I look at my calculator, my Sx is right here, 36.1361. So 36.1361. Divided by our sample size, the square root of our sample size divided by the square root of 20. And now we need to go ahead and we need to figure out what this T star is, right? 4 degrees of freedom of n minus 1. So that's 20 minus 1. Now, I know 20 minus 1 is 19, and why didn't I just put that there? We're in AP class. Well, inherently someone will come back and say, Miss Opal, where'd you get the 19? Okay, so just plugging in the formula just as you see it. So we know that this is 19. Our confidence level is stated as we want a 90% confidence level. Okay, we're going to go to that chart now, guys. Degrees of freedom are 19. Is this row right here? Our T star will be in this row. We want 90% confidence, so our T star is 1.729. Now we're going to go back to our calculator. I'm going to actually calculate this by hand, and I want to show this to you. I'm going to show you a couple different ways here, and there's a reason for that. So I'm going to take, let's see if I can make this a little smaller. Oops. Forgive me, guys. I'm going to take 305.85, and I'm going to add 1.29, oh, 1.729, excuse me. So little, times, now watch how I type this in, 36.1361 divided by the square root. Oopsie. Let's go ahead and delete that. Let's do it again, times 2. I'm not the only one who's done, I'm sure I'm not the only one who's made that mistake. 305.85 plus 1.729 times 36.1361 divided by the square root of 20. And I get my upper bound there. How do I know it's my upper bound? Because I added that margin of error. So that is 318.8208. And then what I'm going to do, guys, is I'm going to hit second enter, which is really nice. What that does is it just takes what I had my previous input and it redoes it for me. And I'm just going to go ahead and I'm going to hit minus. And I get 291. 0.872 or 8792, excuse me. And there's my lower bound and there's my upper bound. Okay, ladies and gentlemen, sorry, my daughter had a question for me. You maybe heard her in the background. So I deposit. Again, if it's disjointed, forgive me. So what we just did is we took our statistic, we added the margin of error to it, and we took our statistic and subtracted our margin of error to it to get a lower bound and an upper bound. Now I do want to show you in your calculator, if we hit stat, arrow over to tests, and get the t interval right here, number 8. And we say, okay, now do we have data or do we have statistics? And we have data in our calculator right now. And our data is in our L1. We leave our frequency at 1 and we say, hey, we want to calculate a 90% confidence interval or construct a 90% confidence interval. If I wanted 95, I could change it to that. I can also go ahead and do this and hit enter. And you can look and you can see, hey, look, it just created my lower bound and my upper bound without having to do that extra work. Now there's times when we have to do that extra work and I'll show you that in the next slide. Okay, lastly, let's conclude. Okay, I am 90% confident. The interval from 291.8792 to 319.8208 contains the true, what now, not proportion, but mean. What is our context? Well, we wrote it up here, the true mean tension for all screens produced on this day. Now, a couple quick review things. This is interpreting the interval. If you're asked to interpret the level, we did that in the last unit. Make sure you have that definition down. That's not going away. Interpreting the level. Get that definition down. Look at your notes from our previous unit. Make sure you have that down. I'm not going to spend the time on the video to go through that again, unless someone has questions about it in class. Another thing, there could be a follow-up question. Like the boss thinks that the level is at 320. How would you respond? Well, 320 is not in our 90% confidence interval, so we don't have any evidence for that. Okay, that's another thing that we practiced on the last unit that could pop up again. Now, I know some of you may feel comfortable with this and you want to hit stop. Please don't, because there is a little bit of a curveball that can get thrown to you, and that's in this problem right here. Sometimes we have to do the do by hand and we cannot use the calculator T interval, and I'm going to show you that here and why we do that. A survey of hospital records of 35 randomly selected patients suffering from a particular disease indicated that the average hospital stay was 10 days with a standard deviation of 2.1. This is average hospital stay, X bar. This is describing N, our 35 randomly selected patients. This right here is our SX. So, ladies and gentlemen, this is our statistics, not our data. So technically in our calculator, we could do a T interval given statistics. This time we can't, but I just want to show you that. Like, you can go ahead and you can type in statistics as well. When they give you an X bar, an SX, a sample size, and what confidence level you want to, construct for your interval, you can do that. But there's an issue here. So how do I know when I can't do it? When I have to do the do by hand? I'm not going to go through the state, the plan, or the conclude. We're just going to talk about the do right now. We want to find a 99% confidence interval for and interpret what it means. Let's just find that interval. So we know we have X bar plus or minus T star, okay, times S of X over the square root of N. Okay, we know what our X bar is. That's 10. We know what our standard deviation is. Our standard deviation is 2.1. Divided by the square root of N, we know what N is. That is 35. Now our degrees of freedom, which you do need to show your work, or like not necessarily show your work, but you do have to show it as part of your work. Your degrees of freedom are 35 minus 1, which is 34. Now here's the issue. Let's look at our chart. We don't have a 34 right here. Okay, we don't have a 34, so we need to round to 30. Where'd it go? Round DF to 30. Whenever we round, ladies and gentlemen, whenever we round, the learning here is we must calculate the interval by hand and not use T interval in our calculator. I'm going to talk about why in a second, okay? So let's actually find the T star for a rounded degrees of freedom to 30. Excuse me. Okay, 30 is right here. Our T star will be in this row. I believe it wanted a 99% confidence interval, so let's go back there. 99% confidence gives us 2.750, so 2.75. Here's our T star. Here is our standard error of the statistic. Let's go ahead. Let's go to our calculator. Okay. We have, I'm going to quit. I'm going to hit 10 plus 2.75. I don't know why, but I always like doing the upper round first. Okay. 2.1 divided by the square root of 35. I'm going to hit enter, and I get, for my upper bound, 10 point, let's see, what was it again? 9762. That's my upper bound. And then again, to calculate that by hand, just keep in mind, all you have to do, which is really nice, so you don't have to retype it all in, is hit second, enter, and it puts your previous input right below there. And I'm just going to change that plus to a minus. Saves you a little bit of time. 9.0238. Now I want to show you something with the calculator here. Okay, so if I go to test and I go to T interval 8, okay, and I hit stats and I say, okay, why did I hit stats? Because I didn't have data that gave me stats over here. I put my X bar as 10, my standard deviation of 2.1. I have 2.75. And my sample of 30, calculate that 90% confidence interval. And what's it 35? I already screwed that up. Sorry, guys. Let me go back. At least I caught it here, right? T interval 8, 35. Go ahead and calculate. And I think it was 99% too, so 0.99. I really rushed through that one, didn't I? Sorry about that. Okay. And now what you can see, guys, it's not off by much, but it is a little bit different. Our interval that we got when we did it by hand was right here, 9.0238 to 10.976. But the interval the calculator gave us is 9.0315 to 10.968. Now, if you would put this here, this interval over here as your answer, you would actually be dinged just a bit. Because what they did is they use the exact T star. The calculator knows how to get that exact T star, okay? They didn't need to do any rounding. So if you do this work here, but then write down the calculator work, you'll get dinged a little bit, because when you type this in your calculator, you should get this right here. But you didn't write that down. You wrote down what the graphing calculator gave us with the exact T star. So it doesn't match up perfectly. That's why, okay, when you're rounding your degrees of freedom, or you could go into the calculator and say my sample size was 31. I'm just trying to stick here. Just do it by hand. Again, if you want to do it another way, so make sure you get the perfect one, that's fine as well. But just the overall lesson from this slide here is, hey, when you have to round, calculate the interval by hand. Don't use the T interval, because the math doesn't work out perfectly. Okay, the math does not work out perfectly. All right, we have one more thing to learn, but I think we're going to be done for the day. We've had a lot going on this little session here. And I'll just teach it to you guys live, I think. Have a wonderful day, you guys. 10 minutes of teaching live, I think will be good. And that's just about finding sample size.